Starting off with question 5, guys. What we're trying to do is we're trying to get G on its own. Is that correct? G on its own. So, what they want us to do here is we got P equals G over 5 plus 3H. Our problem comes in the form of the denominator. How do we solve the fraction problem? Sean?
Make it 5p over 5.
5 on the bottom, 5 on top.
15h over 5.
5 on the bottom, 5 on top, and you're one step ahead of me. It's going to be 5p equals, sorry, it's not, that's meant to be G, that's covered, plus 15h. Want to get G on its own, so how do you get G on its own then?
Bring 15h over.
And 5p minus 15h equals G. Most of you are on board with that. I think just the way they wanted you to do it just confused you. There's nothing more than that. Move on?
Yeah.
Okay, next one then. This one here. Okay, which one was it? Part 2. Okay, AB minus 3A equals 5. What do we do now? Yeah.
Bracket.
Yeah.
A bracket B minus 3.
Yeah.
Equals 5.
Yeah. After that?
A equals 5 over B plus 3.
B minus 3. Because A is being multiplied by the B minus 3. When the B minus 3 changes size, it enters division mode, which is 5 over B minus 3. Yes, Mark?
I'm going to be close to it.
No, see, what happens here is if I said 5x equals 15, yeah? You tell me the answer is 3, wouldn't you? Do you notice that the 5 didn't turn into...
Sorry, that as well. I'm just kidding.
You good? Okay, so that what we have here is you had a question for me. So what I was saying is, you notice that 5 didn't turn into a minus 5.
Yeah.
In the same way, the B minus 3 stays as B minus 3. Same rules apply. Okay, what about question 8? Lucas, yourself, you want 1 or 2 of them done?
Yeah. I'm not sure which one we'll go checking.
Probably should know. Okay, anybody else? Anything on question 8?
5.
8 part 5, okay? So,
Sorry, 8 by 6.
okay, 8 part 6.
Well, actually.
Would you want 5?
Yeah.
Okay, x equals y minus 2z all over 3. Now, what happens here is, guys, the 3 is causing the problems, right? So, we put 3 on the bottom, 3 on top. Gone. I'd like it to be a plus set. That'd be handy. Yeah.
Sorry for
1 second.
a few couple of guys from us. Gosh.
What happens here, guys, is we bring the 2z over the other side and the 3x to the right. So we get 2z equals y minus 3x. Everybody happy with that? 2z equals y minus 3x. And then this 2 here, where does that go? Z equals y minus 3x all over 2. Alright, guys. Everybody happy with that?
Yeah.
What about number 6? What do you think about this one, guys? Yeah?
For a lot of the questions I got like 3x plus y or something like that, like different instead of like x being minus.
Or you're being a bit vague, I need a specific question.
Yeah, when it says like minus 3x, like I was doing plus 3x by x minus there's nothing for carrying that over.
Lads, the only other acceptable answer I can give you is this one. You can multiply top and bottom, but you could have another acceptable answer of this would be minus 3x plus y over 2. Is that what you're talking about?
Yeah.
That's the same answer.
Alright.
So is that what you're saying, Luke?
Yeah.
That's the same answer as that one. They're actually the same thing. It's like me saying minus 4 plus 2 is the same thing as 2 minus 4. They're the same thing. So everybody understands the reverse around is actually the same answer. Okay, there's no difference. Is that right?
Yeah.
Now, what about number 6? What is the problem with number 6?
4 and
4 and a 2. What can we do to fix that situation?
make everything 4.
4 bottom, 4 top, 2 bottom, 2 top. Is that right? 4a equals 2b minus 3c. Which letter are we looking to get on its own? B. Now, Luke gave me a nice trick, I have to say, and do you know why 2 plus 1 equals 3, yeah? We could also say 3 equals 2 plus 1. What Luke might suggest is, why don't we just write it as this? Saves a lot of the hassle, doesn't it? And then just bring it over to 3c. What do we get then?
4a plus 3c.
And then finally went to 2. B equals
4a plus
3c all over 2. Is that alright? We're good. It's gone. We can get back here. Alright guys, so where's the problems kicking in here then? You want to tell me, or can anybody give me another acceptable answer of that one? Another version that's also acceptable? Yeah.
3c plus 4a over 2.
3c plus 4a all over 2. Same answer. Okay. Now, question 12. Which ones would you like me to do? Okay. All of them would take up a lot of class time, so we're going to go for 8. We'll go for 6. 1. Another one? 2. Okay, I think that'll be enough. I think they're all the same tricks. If you still don't get it, we'll do another one. Okay guys, get set on its own. Now, what's preventing this from being on its own is diffraction. So we get 4 on top, 4 on the bottom. Everybody happy with that? What are we trying to get on its own? Z. Cancel. 3z to the left, 4x to the right. 3z equals 2y minus 4x. Who's okay with that? Once again, looking to get z on its own. What's preventing the z from being on its own?
3.
So where does the 3 go? Z equals 2y minus 4x all over 3. Any questions? It's not too bad, is it? Or what about part B? What's stopping B from being on its own?
3 and 4.
The 3 and the 4. Step 1, get rid of the fractions. John, how do you get rid of the fractions?
You have to get the same on the bottom on both sides.
So what would be a good number to choose to be the bottom?
12.
12. So how do you turn this into 12?
Multiply by 4.
This one?
Multiply by 3.
This one?
Multiply by 6.
No, on the bottom.
Put out 12.
12 on the bottom, 12 on top. Multiply 4b plus 9c equals 24a. Bring the 9c out to your side. 4b equals 24a minus, and then finally
b equals 24a minus 9c all over 4.
You happy enough with that? Okay. Any questions?
Yeah, it's not got rid of it.
Yeah, I'll just rub out the other side. I'm working in segments now. Okay, guys. Next one. Any ideas how to do the next question? P over Q equals Q over T plus 1. It's a difficult one, actually. Okay, lads. What do you think?
You multiply the Q1 by T.
That's a good idea.
And then the 1 by
T there, T there. Now you have QT, don't you? Q here.
Apologies for interrupting classes. Firstly, a note to all first year students that rugby training today is
Now, happens next is Q on top, Q on the bottom. What's QQ? No, Q multiplied by Q. Q squared. Now, on the bottom,
QT.
and then on the top, QT. What is 1 QT? QT. Now, what happens to all the QTs? Then, which letter are we getting on its own? Which letter are we getting on its own? T. How many T's do we have? 2 of them. Bring both T's to one side. Now we have PT minus QT equals Q squared. Now what do we take out next? We have to take out T. Have to take out T. So we get P minus Q equals Q squared. Can anybody tell me when we want to get T on its own, what happens to the P minus Q? Goes under. So T equals Q squared all divided by P minus Q. Difficult question, I have to say, difficult. Okay. Now, after that, what we have is part 7. Okay. Now finally part 7. Part 7, we have P equals QR all over Q minus R. Can anybody tell me a good idea how to start this one? Yeah.
P over Q minus R.
P is going to go over Q minus R, and if it goes over Q minus R, it has to be multiplied by Q minus R on top. Isn't that correct? If I multiply something on the bottom, I must multiply it on the top. And that equals QR over Q minus R. What happens to the Q minus R's on the bottom? What can I do next? PQ minus QR. Letter that we need to get on its own? Or. One suggestion we do is we bring this one to this side, and what we get then is PQ equals QR plus PR. Then we do the Luke move, the Luke maneuver. We spin it around. And then we look at the R's again. How do you turn 2 R's into 1?
Multiplied by
Not multiplying.
Squared.
Factorize. Factorize. Or, sorry, you might have been trying to say R multiplied by Q plus P, which is another way of explaining it. And now what happens to the Q plus P? Goes under. That's you done, guys.